students, welcome back. Let's continue with our DDA algorithm, that is a digital differential analyzer. So in the previous video I explained what is a line and what is the slope of a line, and with the help of the slope of the line how can you draw the line segment by using the DDA algorithm with the help of three cases. Okay, so let me recall just case 1. If m is greater than 1, if let me take this, if m is less than 1, so whatever I have written I'm just writing. If m is less than 1, xn is equal to x1 plus 1, that is a y increment is equal to y previous plus m. In the case 2, if m is greater than 1, xn is equal to x1 plus 1 by m and yn is equal to y1 plus 1. And case 3, that is if m is equal to 1, xn is equal to x1 plus 1 and the yn is equal to y1 plus 1. So just I copied the formula cases. Okay, now let me explain this algorithm. So first step, what you have to do, the main aim is you have to draw the line segment on the coordinate. Okay, you have to draw the line segment. So you know the starting point and the ending point, but how you have to draw that line? You need to know the intermediate points also to draw the line segment. So how you're going to find these intermediate points? By using this DDA algorithm. That is a question. Okay, so first accept the start and end point coordinates, that is the x1 y1 and x2 y2. So this is the x1 y1 coordinates and the x2 y2 coordinates. So first you have to accept those coordinates. Now start. Calculate dx, that is x2 minus x1 and dy y2 minus 1. Means let us take, this is a point. Okay, starting point x1 y1 x2 y2. Okay, you want to find out the difference of, that is dx. Okay, so dx, this is the difference x1 minus x2 and this is the dy. This is a y1, okay, y1 and the y2. So you need to calculate, this is a y1 point and here it is a y2 point. So the difference in x and the difference in y you have to be calculated. Okay, or if absolute of dx, this is the absolute of dx is greater than the absolute of dy, means here dx is greater than the dy. If dx is greater than the dy, then obviously m is less than 1. So that is I said here, if m is less than 1, you have to do this, use this formula to find out the new coordinates, the next coordinates in the plane. Okay, so if absolute of dx is greater than the absolute of dy, then the k becomes the absolute dx, else k becomes the absolute dy. Okay, it's based on that conditions you have to be proceed. After that, you need to calculate delta x is equal to, that is the difference in x2 minus x1. Delta x is equal to dx by k, delta y is equal to dy by k. So don't be confused. I'll explain this algorithm with an example. Then you will easily understand what this algorithm is. So with the help of the example also you can write the algorithm. Okay, no need to by heart it. If you aware of this example, then with the help of the example you can write the algorithm. Means in both the way. Okay, if you didn't understand this topic, you can take the help of the example and try to elaborate the algorithm. Initialize x is equal to x1 and y is equal to y1. Means whatever the values that you got, that should be initialized to the new coordinates. Then you have to display that new coordinates x comma y. After that, this x, whatever the coordinates that is present now, that x is equal to x plus delta x and y is equal to y plus delta y, that you have to be calculated. Means the increment value you will get, the next level of the coordinates. Then display pixels, that is whatever the values that you will get, that you have to be round off. round off the x value means suppose 5.2 is there, you have to be round off it 5. Suppose 7.8 is there, you have to make it as 8, because above 5 you have to make it the next number. Suppose 6.3 is, you have to write only the 6, the round off of 6.3 is, and 5.6 is, let me take 4.6, the 4.6 is, you have to take it as a 5. So that is the rounding off. So after calculating this, whatever the xy values you will get, that you have to be rounded off, and repeat these steps 6, 7, 8 k times, means until you reach the end point. Okay, let me explain you the advantages and disadvantages here. Advantages of this digital differential analyzer is, it is a faster method when compared to direct use of line equation. So rather than using the direct line equation, if you follow the DDA algorithm, it is very fast. This method does not use the multiplication theorem. It allows us to detect the change in value x and y. So plotting of same point twice is not possible. So it is going to be helpful to change the values of x and y. So by detecting this, there is no chance of getting the same point twice. This method gives overflow indication when a point is repositioned. And it is an easy method because easy step involves just 2 additions. Only just 2 additions are there. X is equal to x plus delta x, like that. Only just 2 additions are required. And now coming to the disadvantages. The disadvantages are, it involves the floating point additions, rounding off is done, and which accumulates of that round off errors, causing the errors. So here we are just doing the round off. Suppose 5.8 is there, we are just making it as a 6. Suppose 2.3 is there, we are making it as a 2. Okay, it is increasing and here it is decreasing. So because of this rounding of the numbers, there may be errors. That errors may be occur. Rounding of operations and the floating point operation consumes lot of time. Okay, consumes lot of time. It is more suitable for generating the line using the software, but it is less suited for the hardware implementation. So if you want to develop any softwares, you can use the DDA algorithm to develop any software generating applications, but in the case of the hardware implementation, this is less suited. Okay, so in the next video, I'll take some examples to explain what is this DDA algorithm. Thank you.